that's about the question paper. So it was simple directly from the slide. So if you have written something more than the slides, which was not required, yes, of course, that constraint is there, right? So suppose you have written something very genius type of answer, but I cannot expect every other person who has done the course to write that answer, right? So
No,
I have to give
yeah.
the full mark only for those who have concentrated on the slides, understood that concept and applied that maybe 10, 15 concepts what we have discussed. I guess that's the maximum. And only those 15 concepts, either of that should be part of the answer, right? So that is there,
Sir,
but
even
I'll check. I'll check with your answer. If it is too much like very good, I'll take it ahead. Okay, you can ping me. So I don't
Sure,
want
sure.
to
sir, I shared a
discourage
mail
people who
on
read
this to
more.
you
That's
yesterday.
obviously right. Yeah,
Yeah.
Smita, I saw your email, but I didn't get so much time to read it fully.
Okay, sir.
No, but I was traveling. So in fact, I reached just 1 hour before. So
Okay,
I'll
sir.
check your email. Okay, I'll respond. You have attached the answers also, right?
Yes, yes, sir.
I'll check. I'll check. So, but we cannot see everybody's answer. But I'll check because you have written so many emails. I'll check that. See, I don't see. I always appreciate if you leave the marks. Reading extra is always good. Okay, but marks it's little complicated. I don't know how I can describe it. If I give to somebody, then others will become. See, whenever I give mark, right? So I always think about everyone in the class. So it should not go biased, right? So that's the point. Let's see. So if
I
it
get it, sir.
is
Yeah.
correct, yeah, Srinivas, for you, I'll tell you, if your answer is more correct, like it is apt for the situation and it is very good, I guess you should deserve full marks. Okay, I'll check that. Just ping
Okay.
me. Okay.
Yeah, sure, sir. Okay. Yeah. Thank you.
Yeah. Mahesh, do you have any questions?
Yes, Bhagath sir. Bhagath sir, on the regular examination, day two, I missed both of the examination. I mean, I had GNN and conversational AI both, so I missed both of them.
Mhm.
So for makeup, so will it be the same portion like you explained in the session 8, or you are going to consider today's lecture as well in the makeup, sir?
Mhm. It will be same only. How can we
Okay,
consider
so
extra, right? It's not possible.
okay, okay, sir.
Will be unfair if the syllabus
And
is
and
same.
and And the pattern will be in the same manner, right, sir? Like you explained in the end of the sprint, end of the eighth session.
What pattern I mentioned, right? I don't think I
I mean,
mentioned any
pattern
pattern.
is
What did you understand from that?
so sir, before preparing the examination, we gone through. I personally gone through the all PDFs and the I took it as a important questions and I gone through those things and those helped when I came to know on the regular examination questions, right, sir? So that's why.
Mhm.
So I need to appear the examination in the makeup. That's why I'm asking, sir.
Yeah, I understand. Yes, yeah, you are. See, I will not restrict only based on the revision topics. As I already mentioned, right? So it will be biased on those people who have given regular. So because the revision topics, I guess I mentioned around 10 or 12, right? So maybe I
Correct, sir.
left 5, 6 topics in the slides, right?
Hmm.
So point here is 10 or 12 minus the regular questions. I think everyone has the regular questions. So will be around 6 to 7 topics. So I don't want you to read only that 6 to 7 topics. You understand, right? So some
Yeah, yeah.
questions will be repetitive. Maybe it is both in the regular as well as makeup, as well as some topics which I have not discussed in revision might also come. Okay.
Okay, sir.
So why I say this is not to confuse you, just to make sure you read everything, right? That's good for you, right? It's as
Yes,
simple
sir.
as
Yes, sir.
that. Yeah,
Yes, sir.
correct, right? So I hope that is sufficient. No, I cannot confirm that, okay, it will be from only revision topics or not. Okay, that's the
Okay, sir.
point. Mhm.
So,
So
sir,
But
given
it
that,
will be easy. Don't worry. Nothing we. Yeah.
Yes.
sir, is the makeup paper fully being checked? I mean, all the questions have been checked because I see some of the questions are not are been marked 0 with no evaluator comments. Although I have I mean attempted all the questions over there. So I mean, is this
Okay.
I mean some of the
no, there
I
is
mean
regular.
are those
Actually,
No,
you're
no, they
talking
are
regular, right?
they're
They are
checking one by
checking.
one. So
It's
They'll
still in
they
check
are
one by
progress.
still in
one. I think it
progress.
will you
Yeah.
you please check after some 10, 12 days. Like before by makeup exam, your regular questions, everything should be done. There is one prof, actually one learning faculty who has to start, but there was some issue in the portal. So he couldn't start. I think one question for each of you would have not been surely evaluated because he has not yet started at all. So other than that, I think it should have started. But please check after like just when makeup exam is happening. Okay, that will be the right time
okay?
to check and understand. Okay, whether every question is corrected or not. Okay.
Yeah, because some
So
partial marks are already there on the portal.
yeah. So see, I'll tell you how it goes. Like it one faculty will be concentrating on one question. Okay, so there are 5 questions, so 5 faculty will be there. So maybe one person completes has completed the his complete evaluation. So which means one question for every student is evaluated. I hope you understand the logic, right? Accordingly, you
Yes, sir.
can
Yes.
follow. Hmm?
Got it. Got it.
Okay. Yeah.
Sir,
Okay.
one point.
Yeah,
Sir,
yeah, yeah.
one point, maybe before we start on the assignment, sir, I pinged you offline
Mhm.
also. So it's not about the marks actually. It's about, I got I mean, obviously a very small, like 0.5 marks has been cut. But the reason stated was
Mhm.
that the font and the bullets and numbering, and it was those trivial or cosmetic things that was pointed. And it was said that this time it is lenient, next time it will lead to greater deductions of marks. So
Mhm.
until this semester, a majority of our previous assignments were all code based. We've not done anything on the name of preparation of presentation. And I didn't,
Mhm.
I mean, if there were, I don't know if there was any mention of the cosmetics, the fonts, and all these sizes. And if that really is a constraint on the evaluation, please let us know, sir.
Okay. Yeah, yeah. I have kept your message still unread because I wanted to check it. I guess you have pinged me many times. I have also replied to you, right? So I'll check
Yes, yes.
what are some days because I
Thank you,
was
sir.
in vacation. This is the holidays time, right? So kids are free; they're not allowed us to work. So just maybe another 1 or 2 weeks, it should be done. Yes. Okay.
No worries, sir.
I'll
Thank you very
check
much.
personally and then I'll get you back.
Thank you, sir.
So
Hope you had a good vacation.
yeah, it's going on, still not over. I'm at my hometown. That's why I don't have my extra monitors, this laptop. Okay. Can you all see my screen?
Yes, sir. Yeah.
Just I shared one window. Okay. So yeah, I hope a lot of things are there to check. I'll check this weekend, maybe tomorrow or next weekend when I'm back. Next weekend will be, I think, makeup exam, so I'll be completely free. So I'll check things in detail. Okay, so it should be fine. Another thing, what else? Yeah. Think question paper was fine. Okay, yeah, I think your assignment 2 will be out by Jan 6th, if I remember, Jan 6th or Jan 9th.
Jan
So, and
6th or
one
Jan.
more, yeah, Jan 6th, right? Yeah, yeah. So, to complete it, that will be coding based. Okay. So, and yeah, just thought, yeah, you were like somebody mentioned before this, everything was coding based, and this time it is not. So, do you feel that's a negative point or what? Is it good to have coding based or it's fine to have this PPT? I guess I
Sir,
mentioned why I gave PPT.
Personally, I really liked the way how the assignment was given. Coding anybody could do
Okay.
using ChatGPT, but this was tailor made very narrowly to make sure that nothing from ChatGPT can be taken. I really like this, sir,
Mm.
if you ask me
Okay.
personally.
Okay. Okay. Yeah, because I just had a doubt.
No, sir,
ठीक
assignment
है.
format is good, and only thing
Okay.
is some comments were not exactly directed at our
Mhm.
effort. So we just want to cross
Understood.
check if that was really considered or that was given at the last minute, something like that. For
Yeah.
example, formatting, many of us might not have focused, like some of us might have
Oh, don't
focused
worry. My
because,
assignments is completely with me also. So
okay,
if you have any queries, so let me know. Because see, correcting people also keep changing, right? So we don't have a stubborn team, right? So like a fixed team. So people come and go. So new people will have a different style of correction. So I have not mentioned that. So I will put it in the group also
yeah,
what
we
they
just
should
wanted to
think.
have that
Yeah.
communication understood. That's
Yes.
why we got it to notice.
Yeah. Yeah.
And
I'll
second
I'll
assignment
ping
is
that.
due on January 15th, sir, not 6th. I just checked actually. So
15th.
yeah, 15th.
Yeah, yeah, I'll get it. That will be coding based, and we'll see how best we can get it done in a very different way. Okay. I
Sure, sir.
think.
Looking forward to it.
Yeah, don't expect so much. I don't have so much time. Office also so much work is there, but I'll try my best to get something good. But for sure, I'll make it something useful for you guys. Okay, coming back to the today's lecture. So this lecture will be for two sessions today and after your makeup exam. So we'll start with the catastrophic forgetting. So why do we go for RAG, right? So main thing is catastrophic forgetting. It is basically we are trying to tell that okay, you fine tune so much, the LLM will start forgetting things which it has learned during its pre-training phase, right? So we have to consider some amount of learning, some amount of tuning the models so that it is able to uh, understand the new logic or new pattern in which it has to give the output. Okay. And some keywords it can learn. Like, for example, you have taken a very generalist model and then you wanted to fine tune it for a particular domain. For example, banking domain, right? So you wanted to fine tune it to learn some jargons of banking. But if you wanted to keep on fine tuning on that banking sector, so what happens is it will start forgetting the generalist knowledge. So which is also important, right? So as you grow up, so maybe in the what do we see like in our careers also when we come out of our school, we are mostly generalists, right? So when you come to UG, PG, we are all more technically grounded, right? Particular department, right? Whatever it is, the branch. But then as you grow up in your career, so at a point like after 15 years, you really need technical knowledge to grow after that? No, right? You require technical knowledge. I don't say disagree with that. You require some part of it, but then you have to become more again generalist. That's how you climb up the ladder, the managerial leaders, right? So same thing. So you should not forget, but if you forget how to be a generalist, that's a problem, right? That is what is we are going to discuss on the first line is the catastrophic forgetting. Okay, so what is the like how can we kill it? That also we'll see mitigation of that logic. So mitigation is RAG, right? RAG is also one thing uh, which you can also make it to learn new things, but that's a temporary stuff. Like you wanted to learn for like somebody invited me for a guest lecture. I don't forget everything in my office, right? So I just have to find like short term, temporary situation. I'll fine tune with a lot of facts and concepts, and then go and deliver that, and then I'll forget it. That's what I do it. The same thing here, right? So when you are using RAG, what you do is in real time, you fetch the facts which are related to the particular situation, right? You fetch it, use it, and forget it. There is nothing you keep it in your memory. So that's many times good, right? So that you can more and more load new facts and new concepts. So that till maybe a short term, 4 or 5 days, you keep it, use it, and then leave it. Same logic is with RAG. So RAG is that's what I guess you guys would have already learned in the starting. So we'll see that RAG next. Okay, after this, then we'll see how in depth we'll go about how to process the documents, how to get, because this is more related to company stuff, right? So in company, how do you process the documents? It's a very this was not there the last semester. I added here because this is a very important thing. This is where I take a lot of time. In fact, most of my RAG concept, 50% of the time goes in document processing. Document processing also includes document understanding. So you should understand what you wanted, what do you want your LLM to take from that. It's not that every PDF is same, right? So you have to understand what your LLM has to understand from it and how do you process it. So that is very important. So it's like there is a very famous verse, I don't know who has mentioned. It's like garbage in, garbage out, right? So if you give a garbage, LLM will give you garbage out, right? So it's like that. So if you give a good quality data, it will give you a very good output. LLM will not at all hallucinate. So two things you have to keep in mind. The quality of the data should be very good, and the quantity should be apt enough so that your LLM does not hallucinate, right? So it's not like that you prepare a very good quality and dump everything into LLM. No, right? So you prepare a very good quality, but you dump exactly what is required for LLM to understand. It's not that you build a very good pipeline, just that you retrieve everything and then put it inside LLM. No, you have to retrieve everything in a most nice way LLM can understand. That's the first part. Second part is you have to feed LLM only the right thing at different levels. There are different hierarchies also. It's not just that you just extract the document and keep it and vectorize and keep it, and then you just feed the LLM with that particular chunks. No, there are different options to reduce the, there is called LLM compression of the context, right? So there are different ways to compress and then feed it. Then let LLM understand that and then let it decide whether it wants more detailed information out of that chunk, some compressed chunks or not. If it wants, then you feed in the more detailed chunks, right? So it's like hierarchical chunking. So there are different ways we'll go through that. Okay. And fourth one is the apply. So it's like these three things, but there are four, I think two more things also. We'll go through the slides, that time you'll understand. Heidi, multi-query, and re-ranker. Basically, it is the first two is more of query reformulation. You can say it's like query understanding or reformulating the query to, because users don't think in terms of LLM, right? So the users think that, okay, this anything they wanted to just speak in natural language, right? But as an intermediate step, you have to build this point such a way that it takes the user query and reformulates it in such a way that LLM or your workflow will be able to take it in a most contextful way, right? So this step is very important. If you add this step, most of your, not just these two steps, we will see that fully, but this is what I was trying to say is query reformulation. If you add this in your any production systems, this makes so much difference, right? I can guarantee this makes at least 20 to 30% very good retrieval as well as LLM's understanding. Okay, So that's a very good. Even when you are using MCPs, this is going to help you so much. Okay. So keep this in mind. MCP also can reformulate, but you try to reformulate it before even feeding it to MCP. That is more intelligent way. Okay. So we'll see how this is done. And then re-ranking is, if we have seen till RRF in our, I think, second or third lecture, but we'll see about re-ranking. What is re-ranking? What does it do? Okay. So in that part, you will also discuss about encoders and decoders again, once again. And then few RAG architectures, added some of them. Few of them, I think I have added new things also. Yes, I think 2 or 3 I have added new architectures than last semester. Okay. So then finally, we'll see the agentic RAG systems with routing and self-reflection. Okay. So very interesting topics. So do please learn these whenever you get time before your final exam. As I always say, like a very typical prof, forget about the marks, learn it, because this is going to be very useful. Okay, that's what I feel, because I'm in the field, I can see it. So I hope you will also appreciate it. Okay. So now coming to catastrophic forgetting. Okay, so from this diagram, can somebody understand, like explain what does it try to say? I'll zoom this. Okay, just see this and try to explain what does it say in layman's language.
It's overfitting and it lacks generalization.
Ah, okay. Okay. Anybody else? So what could be a solution for this? Okay, your point is correct, but what should be the like what could be a answer for this? We have learned some topics. So I'm not asking a very innovative answer for here. What I'm trying to, what I'm expecting here is, think of all the techniques what we studied before mid-exam, and which of the technique could resolve this. There's some concepts, right? We read, which could
For
Regularization.
caching will help, sir.
no, not caching. Somebody else?
Regularization.
Pardon?
L1, L2 regularization.
It is not eliminate regularization. There's something, you are almost near to that. Yeah, pardon?
Adapter based fine tuning instead of
No.
reparameterization. Okay.
Adapter, how does it help? No, it is not the correct answer, but I just want to understand how you are saying that it is adapter based. How can adapter based give you generalization?
I mean, instead of forgetting existing, updating the existing weights, we will plug in an adapter which will change the model's weights based on the specific domain of the runtime. We will plug in the adapter, like plug and play types.
No, let's see. In adapter, what do? You either can see once you are fine tuned with adapters, right? So now at the inference time, you either have an option to use the adapter or not use the adapter. Correct.
Yeah.
So if you use the adapter, it is learning task 2. If you don't use, then it is learning task 1. Correct.
Yeah.
So there is no intermediate generalization, right?
So some kind of LoRa or QLoRa fine tuning.
No, correct. See, fine tuning karna hai. Like you have to do fine tuning, But you have to add something, right? So somebody told about the L1, L2 regularization, right? So just leave that L1, L2. Consider regularization. So in your DL also, you would have learned about regularization. What does regularization do? While learning new things, it also ensures you are not forgetting the old stuff, right? You're grounded. Correct. If you remember, we learned that, right? In DPO, PPO.
KL
You remember that?
divergence.
Exactly. Very good. KL divergence is the answer what I was expecting. So
Yeah.
that is what is keeping you grounded, right? So that's what is the other part is it races towards the highest rewards, right? So, but that is not what you wanted, because if you keep racing towards the highest rewards in PPO, you may forget what is already learned during the pre-training. So what we do, we keep a check. That check is called KL divergence in PPO, right? So that is what exactly is to be done, so that it ensures it doesn't learn too much. Correct? It doesn't. It is not not learning too much. Sorry, it is. It doesn't deviate too much from the original set of weights, such a way that the earlier knowledge learned during pre-training is forgotten. Right. So that check we have to keep. That's what the KL divergence does. Okay. So that's what I wanted to say. Okay, you will see that. So in one is the regularization method. Okay. So there are many ways you can use regularization. This is elastic weight consolidation is also one type, but what you have learned in RL based, that is also very good. Okay. So in reinforcement learning, you learned about KL divergence, right? So that is the best way you can understand and learn from. Okay. So here what they're trying to tell is this is progressive neural networks. This is the second one, architectural based method. Architectural based method, what we do is, so if you see here, so at every stage, we are having an adapter which will take an input from the previous stage. So this is a different method than the KL divergence. KL divergence is like you are grounding into the original model's weights, right? So it's just we are grounding it so that it doesn't go away so much. Okay, that is one point. But here in this neural network method, progressive neural network method, what we do, it progressively learns. That's the point what they wanted to mean here. But what we are doing is we are having an adapter which will take the previous hidden layer, okay, hidden layer input, previous hidden layer input, and then use that along with the current input. Okay. So what happens is if you don't have this part, so it's a new learning for this. This is a new learning. This is a time step 2. So it is going to learn new. So what happens? It will keep changing. It would have changed so much, right? But what we are doing is we are also taking the previous step. So previous step means what it has learned previously. Along with that, a new step also. So what happens is this combines. It's like what you are giving is x plus delta x. This is your new x. Okay. So what happens is in this is too much, right? So this is the previous x and this is your delta x, right? So this is how you have to make it learn, right? That is the most optimal way. You should never feed only, so new x if you will just give like for example, you delta x, right? Not delta x, you can give randomly a new x. So maybe it is an x2. So if it is an x2, so this may be completely different from the previous step, right? So previous step is maybe it is x1. So x1 and x2 might be so much different. And what happens is your model will try to learn. Okay. So, okay. What is study? Okay. Here, this is the point. Okay. So you are creating a adapter, a small adapter in each of the inputs. Okay. So each layer has an adapter. This is an adapter based uh, training. Okay. So you are having an adapter which is going to take the previous knowledge and then combines it with the new knowledge and then trains your hidden layer. Okay. Same for the output layer also. So in this case, it doesn't change the weights of the hidden layers and the output layers too much. So it's still grounded. Okay. So that is the architecture based. Reversal based, we'll see in the next one. So this is the reversal based. In reversal based, just go through this. Let me know what you understand from this slide. So yeah. Anybody wants to explain here? Anybody wants to explain here?
No, sir.
Hello.
Not able to get you.
What I will get? Okay. So, okay, what I'll tell you. So only see the last sentence. So what does it say is the last point here. Just see here. So what does it say?
Hello.
Uh, so you're taking an LLM. Okay, you're taking an LLM. This is a very good in math. Okay. So this is currently it is very good. Okay, this is a very good in math. Okay. But you wanted to teach the like for example, English to French to this LLM. Okay, got it. So this is the current requirement. Okay, but what do you do while teaching this? Okay, if you only say if I teach only English to French, that's what we do normally, right? But what they are telling here is rehearse with the selected synthetic instances, which means you have to consider some amount of old data. Like for example, here we are saying that you see here, what they're doing, they are generating few instances of input output using the same element, basically. Okay. So this is its knowledge. It already has knowledge, right? So it knows, okay, this is the input. I have to give this as the output. Okay. Whatever it is.
Is that a mistake or that's what I'm not?
Yeah, no, it is mistake. It is mistake. I'll tell you. So that is why they are doing a refinement. Okay. So this LLM has a base knowledge. You are doing a refinement means to get the correct answer. Okay. So you have fine-tuned it. Okay. So currently you have fine-tuned it. Okay, so what happens is you have fine-tuned this and now it is able to give the correct data, right? But you wanted to remind that with the old data also. So now what you are doing is you are combining the uh, rehearsal data with your current data so that it doesn't forget both the knowledge. You're rehearsing the old data, what it knows, right? It has to know this data also, plus this also. While learning it, you understand what you're doing?
Do you mean like we keep both the data and retrain it? Is that
Correct. No, you will train it little bit. Okay.
okay?
Yeah, but for your question, yes, the complete process of training ensures that, like for example, you are training one sample. Like for I wanted to teach you uh, some new topic. Okay, so I teach you one concept, and then I'll give you a story which you already know, and then explain it, right? So something like that. Be the right example there. Okay, I will not confuse you. What here is you give 1 point of current data, like 1 point of current data, and you give 20 samples of what it already knows. Something like this. Okay. So it is learning new data as well as it is getting tuned by the old data, what it knows. So it will not forget the old data as well as it is learning the new data. Do you understand what I'm trying to say?
Yes, sir. But is it done at the fine tuning stage only, or it's like a complete
It is
retraining
done
from
during the fine tuning. No, no, this is the fine tuning, right? So from here
Okay.
you are doing the fine tuning. Okay. From here you are doing the fine. This is the base LLM. You have done some refinement. Okay. This is during the T minus this one step. Okay. This is the complete process. From this time to T place is the complete fine tuning. Okay. So what we are doing is we are fine tuning here. T minus one step. Maybe you say this is 10 steps. 10 steps you have fine tuned to get a good answer. Correct? This is the first part of your fine tuning. The second part is you're also reminding of the old data.
Got it.
Got it? So what happens is you are using the old data at the fair end so that it doesn't forget the old informations also, apart from the new information. So at the end from t minus 1 to t, what we do, we have a sample. So I'll take like this. You have suppose 1,000 samples for fine tuning. Okay. So you have the LLM. So what you do, maybe you have, okay, you have fine tuned this, for example, and then you got LLM 1, but you don't close this here. Okay. So what you do, you take the old data, which is your original LLM's data, which you have obtained earlier. Okay. So you have to give that data into this. Like for example, you give another 1,000 samples of old data. Okay. And then you parallelly include this new data also, this one, new data. This is new data. Okay. So now whatever you will get, the LLM you will get, this is the version what is finalized. So this also knows the old data. It has not. But here, what is the use of this is whatever this old data, what you are giving, right? So it is going to remember that for sure because you have fine tuned that model again with that old data. But problem here might be still could be is that let's say it may forget the remaining data which is not into this 1,000 pieces of old data. You understand what I'm trying to say? Like here we are tuning the model to mathematics. Okay, so that is fine, but we are also reminding of the model of that English to French. Okay, so now what happens is at the end the fine-tuned model will have both these knowledge. One is mathematics as well as the English to French translation knowledge. But still there could be loss of knowledge, forgetting, like catastrophic forgetting of the information apart from this English to French, right? English to French is the old knowledge, but maybe it also knows English to German. Since you have not added that into this fine tuning, the probability of the LLM forgetting that English to German will still stand hold. hold good, right? You agree with that?
Yes, sir, I agree. Yes, sir, I have a
So
question.
selectively you are using the model so that you know that okay you want your LLM to know be good at mathematics, but you don't want it to forget the English to French. So selectively you are ensuring it is not forgetting that English to French. But in the earlier one, in this one, you're not selectively worried about English to French, right? So it is more general. So it will be like English to French also, maybe little bit is forgotten. English to German also, little bit is forgotten. But here, if your use cases, okay, I am after fine tuning the LLM, I wanted my LLM to do these two jobs. So I am just worried about only these two jobs, nothing else. Then you can go for this reversal method. Okay. Yeah, somebody raised the.
Sir, for progressive learning, the previous weights are frozen or they are also allowed to be changed?
Which previous weights?
I mean, yeah.
No, this is a
We have,
new adapter, right?
yeah.
This is a
So
new stuff.
So
Yeah,
this
yeah,
should
tell
have
me.
weights from H1 1, right? And does that also gets changed?
No, you are changing this. Okay. These weights are getting changed.
Okay.
Sir,
You're
actually,
talking
so
about
what?
the. Yeah, yeah.
Go ahead, sir. Go ahead. You complete that.
And then you tell me this.
I think you compared with this model, progressive neural networks, and the rehearsal-based method, what we discussed just now. In this progressive neural network, you are saying that whatever the old data, the entire data will be added into the new tuned data, right? Right, sir? And the rehearsal-based method, whatever required, like English to French alone, can be fine-tuned and added into that. That
So
correct?
here, so like for example, okay, I'll just reiterate what I said. Suppose your LLM is good at task 1, task 2. Okay. And now you wanted to train the LLM for task 3. Okay. So what do? You train the LLM and then this LLM will become the expert of task 3. Okay. The probability of it forgetting task 1 and task 2 remains same. Correct?
Right, right. Yeah.
Correct?
Yeah.
So like for example, the probability of forgetting task 1 and task 2 remains at suppose 40%. The probability of forgetting. This is the normal thing. Okay, that is why we are talking about how to mitigate it, right? So in architecture-based method, what we are saying is when you use the method, this probability of it forgetting the task 1 and task 2 reduces to 20%. For example, okay, I'm just saying that just a random number. Okay, so we are not forgetting 40%, we are just forgetting 20%. Because we are concentrating to concentrating on all the previous
data also you will
knowledge.
tune. Yeah, yeah.
Correct.
I mean, we will miss some of the hidden one layer, but yeah, right,
Correct.
sir. And
But in this
okay,
rehearsal method, what we are doing is we are fine tuning on T3, the LLM. Okay. Apart from that, we are also interested on T1. Okay. So the tuned model, LLM, maybe I will call T1 and T3, T1 and T3, yeah, some part of it. So this final LLM will be good at T1 as well as T3. But the probable, which means I have reduced. So in this case, in the earlier case, in the general case, it was forgetting 40% of T1 and 40% of T2, correct? But in the rehearsal method, T1 is not forgotten at all. Maybe T2 still stands at 40%. Okay. So 40% T2 it has lost. But T1 is not forgotten, T3 is learned new. This is reversal method. You are not forgetting at all T1 because you are reminding it, right? You are reversing it with the T1's data. Your LLM is capable of doing task 1, task 3. But in the architecture based, you are not doing anything specific for T1 or T2. T3 it will be expert. T1 and T2 it is going to forget, but with the rate of 20%. Okay, that is what is this. But in this case, it will forget only T2. It will not forget T1 and T3. You got it? Here. Is it fine?
And what is the augmented data, sir, in the rehearsal based method DT it is
Augmented
given,
data
right?
is the current data T1 and T3. So this is the new
Okay, T1 and
data,
3.
like for example, new data plus the old data.
Okay.
Correct. So that is good. The
Sir, I have
augmented
a
data
question.
is nothing but it is learning T1 and T3 parallel. So it's like one sample of T3 if you are giving, like one sample of T1 you give, like that. So you keep on reminding. So this is one sample means this is one sample. So two samples it will train, but in that one is the older sample. Okay.
Yeah. Thank you.
Yeah. And I guess just before the next question, I'll tell one thing. So actually, this adapter is only learned. Okay. So the hidden neural weights are not changed. That's what it is written here. I just missed it. Okay. So we are changing only the adapter values. Okay. But the only thing is we are taking it and then fine tuning it. How much percentage of EA has to be considered? That is what is going to be learned by the AI. Okay. But the logic remains same. LLM T3 and then T1, T2, the loss is less. Okay, the loss is going to be not 40% in the regular case. It is going to be 20% because so it's not 20 or 40. And my concern is the loss of the previous knowledge is going to be reduced in architecture based method. Okay. In reversal based method, you are not worrying about the all the previous tasks, but you are worried about, okay, T1 it should not forget. Maybe the earlier LLM knows T1 and T2, but in my future case, I don't want it to surely forget T1. So while tuning for T3, I also add T1 in the sample set. So that's what here it is written. Sample set you are taking and then using that as a sample. From there you select a sample and then add it with the new data so that augmented data has one sample of the old data and one sample of the new data. So it is the LLM is learning both the information at the same time. Okay. So it doesn't forget the old and new while learning the new data. Okay. Yeah. Question.
Yes, sir. Just one. I think you kind of clarified it, but for example, if but even in this rehearsal based, only the adapter weights are changed, not the hidden neural networks weights, right?
No. In rehearsal
Rehearsal
based,
based, you
we are
change it
not
fully.
having any adapter. It is
Fully.
full
Okay.
fine tuning.
Okay. If it's
It
full fine
is
tuning.
same thing like LoRa. So in rehearsal based, it is simply nothing but a LoRa training only. But
Okay.
only thing is your sample set. You are just playing with the input data. Fine tuning, you can do it with LoRa, QLoRa, anything. It's
Okay.
just that you don't want LLM to forget the task T1.
Got it, sir. Okay.
Okay, you're making 1,000 data set. So in that you add 1,000 more old data and then you fine tune like this. Instead of just simply in LoRa, what we do normally, we take 1,000 data set and then input output pair and then fine tune a LLM, correct? But what they are
Yes, sir.
telling in this method is don't take only the 1,000 of new data set and you see if you are not concerned about the old knowledge, then it's fine. But if you are interested, okay, after fine tuning, still your LLM, you want your LLM to perform very good in task 1, which it already knew. then add the 1,000 pairs of old data, and then fine tune it together. Okay. So then what happens? It will not forget the old task also, and the new task also, it will perform very well.
Sir, if I start retraining with these two new data sets and then this
Mhm.
approach, may I know what would be the advantage I get? Since I am
Which one?
anyway considering the old data set and then I am retraining. Right. So let's say I'm taking both T1 and T3 data sets and then I'm fine tuning it. And then instead, if
Correct.
I'm retraining it, like even the term I'm using different, may I know what exactly will happen at the back end and what
No,
advantage do we
see,
get by fine tuning it?
the advantage, see, what do you know? See, like, I will tell you one thing. So here, I think you didn't understand this T1, T2. T1, T2 came from the previous knowledge, a previous training, whatever is the training method. For example, pre-training. Pre-training has brought this knowledge, T1 and T2. Okay. So in that case, oh, yeah, okay, in that case, T3, you are doing it using LoRa. Okay. So you have LLM, which was pre-trained and very good at T1 and T2 task. Okay, got it here? Till here you understood?
Yes, sir, got it.
Now, instead of just see, normally what we do, we pull a LLM, which is good at T1 and T2, and I want that LLM, like instead of T1 and T2, I will tell one. Like T1 is an, like T1 is translation. Okay. T2 is summarization. T3 is coding. Now, could you understand the real life scenario? T1 is translation. T2 is summarization. So your pre-training time, LLM was used to train using lot of language translation books and summarization books, all those things. So your LLM is very good at translation. Maybe specifically you can take some translation like English to Hindi or something like that. And then T2 is very good at summarization. Like you give any big paragraph, big book, it will do a very good summarization. Okay. So these two tasks, it is very good. Now you are taking that LLM. Now your company says, okay, you take this LLM and then fine tune it for a particular task. Coding is a too much different. I will tell, okay, you can say,
My doubt
okay,
was if it's
you,
as newer task like coding or example, right? Then should
correct.
the model be retrained? I mean, fine tuning may not be enough. That was the confusion I had.
Yeah, that is why I wanted to change that task 3. Task 3, you can take like English to suppose Sanskrit, for example. So model is already very good at English to Hindi. Okay. So English to, this is English to Hindi. And this task is, so task 1 is English to Hindi. Okay. And T2 is English to, sorry, this is summarization. Okay. Summarization. And T3, what you wanted to, what your company says is take this model and then fine tune it from English to Sanskrit, for example. Okay. So this is your task. So, but when you are doing this, the probability of the earlier information, earlier capabilities, it may
Should be
forget
retained.
it around. Yeah, it should be retained. It should be retained if it is required. That's what I'm saying.
Got it.
So this is not always you should apply this. Suppose if you are interested, okay, after fine tuning, I'm going to use LLM only for English to Sanskrit translation. In that case, you don't need to worry about all these things. Forgetting also. It will be fine. Okay, because T3 it will be good after fine tuning. But only thing is T1 and T2 it will forget. Correct.
Yes, sir.
But if your company wants, okay, after fine tuning, currently they have LLM in their company. For example, before you joined or you already it is doing very good English to Hindi and English to it is doing a summarization. They wanted, okay, why can't we make the same LLM to do English to Sanskrit also? Right? You also means you want after this training, you want LLM to do T3, T1, and T2. All the three tasks. In that case, you have to go for this, what do you call this, progressive neural network, correct? Because that ensures it doesn't forget T1 and T2 also. But if I give a scenario, like I say that, okay, I want you to, your model, like I have given this is the scenario, like currently I have a LLM which can do T1 and T2. And I'm telling that how will you do this fine tuning of this LLM? What if I want my LLM to do English to Sanskrit and English to Hindi only? I'm not worried about summarization at all. Okay. In that case, I am more interested on T3 and T1 only. You got me?
Got it.
I'm not worried about summarization. I'm not going to use it for summarization. Currently, it is doing very good at summarization, but that is not required because summarization, I have not removed it from my workflow. So I want LLM to do only English to Sanskrit and English to Hindi. Okay. So in that case, you have to go for this reversal based method. Correct.
Got it, sir. But generally, if we take LLM, then we do not have access to the data in which they trained, right? They don't share that.
No, that is what you are preparing the synthetic data, right? Here. The first two steps is the synthetic data. Synthetic data of the LLM's knowledge, what you want to retain.
Okay, got it. Oh, now I get it.
Okay.
Okay.
Correct. So here you have prepared the data which LLM knows. So here you see they have just given one example. Create similar pairs. So it is creating a lot of pairs. And then you will fine tune it and then keep it. This is your input pair. Okay. This is your input. Input pair means this is the old data. Okay. So you are using the synthetic rehearsal data. Okay. This is the old data. Apart from that, you are also making it to learn a new data, new task.
Okay, sir, got it.
And that is what we are taking augmented data. Okay.
So reason behind these LLM forgetting T1 and T2? I know this is a catastrophic forgetting. Why LLM tends to forget T1 and T2? I mean,
Why
just
LLM
curious.
tends to forget? So it is same as like when you read, you go through that RL method, right? So there we discussed this. So when you are trying to, it is more of a regularization. Have you heard about regularization in your
Yes,
ML,
sir.
DL?
Yeah.
So it's same logic. So why do we need a regularization? Is same logic, right? So it's like, for example, I can explain you. It's a very simple thing. So for example, currently your weights are here. Okay. So when your new weights, so it's a capability, right? So this is one capability. And if you want a new capability, your LLM to do a new capability, this is the weight should be at this point. Okay. So what happens? You will, when you are training with 1,000 samples, this weights will slowly move from here to here. It will go to here, for example, after 1,000 samples. Maybe after 2,000 samples, it will go to here, correct? But point is, the original weights had some reason why it is or why it was here, right? So, for example, this is a mathematics. This is a mathematics, okay, and this is creativity. So initially, it is a generalist, correct? So it will do 70% good at mathematics and 70% good at creativity. But when you have trained only samples with mathematics, this weights will be very much pushed towards this part. Correct?
Yeah.
You agree? So, and then the creativity will become too much low. Correct? This is what is happening. So this is in terms of very much English way of answer, but in what I have drawn dots, right? So it is exactly. Have you read Transformers? In Transformers, we have a vector space, right? So in vector space also, we say the same logic. So if you have a vector space like this is, I'll explain you here. For example, this is fruits. This is orange. Okay. This is suppose pineapple, this part. And here you have mobile. And here you have laptop. Okay. So in general vector space, if you take a word apple, okay, so it should be in the center. Do you agree? Apple as a general word, because we have apple as a fruits, right? Apple can belong to fruits as well as apple can belong to mobile, right?
Devices, yeah.
So it is a general point, right? This is the general point. But today I take that LLM and then train it so hard on the Apple, maybe Apple related books. Okay. Brochures, books, lot of articles, all those things. So all these will come here. So this will come, it will not exactly go there. It will come somewhere here. So it has come here, correct? So now if you ask a question about Apple, do you think it will give a good answer? It may hallucinate because you have trained so much that the vector space of that, the vector under the contextual vectors it creates, right? So after every decoder, it creates a contextual vector. That's what it creates. Nothing but its contextual vector. The contextual vector will be more biased on the electronic gadgets for the word Apple. Correct. So in that case, if you query sometimes, okay, apple as a fruit, it will surely hallucinate. So that is why, that is what is called as this called forgetting. So you are pushing it towards a particular context.
Okay. Okay, sir.
Got it?
Yeah. Thank you.
It's like you are making it biased, right? So it happens mostly when you are having a lot of biased information. So that's also we'll see, I think next to next class, we'll talk about that more. How to kill that bias and how do you ensure that your models does not be go into give like it to stop it to give biased information. But for that, you should understand what is the bias it is giving. That is what we have red teaming and all, right? In your companies, if you are implementing AI, you will have red teaming done at the AI governance level, right? So in that time, their team, their governance, AI governance team has to look into all these parameters. As developer, you don't need to look into it, but as a AI governance team member, you should think about all the biases possible. Biases is not just male or female or this kind of electronics fruits. So all the biases which is not acceptable by your company's products output has to be searched and found, and then your model or your workflow has to be tested on that logic. Okay, so that is the correct AI governance team. Okay. So we'll not see that much deep, but we will see what we how we can do that. And if you belong to that AI governance team, you can utilize that. Okay. But as a developer also, you should know, because when AI governance team will discuss all these things, you should know, okay, these are all important things, right? Okay. So to kill that biases only, we have to ensure that you're fine tuning data. See, like for example, my previous organization, so I fine tuned the model. Okay. So not just the model they will test, they will also look into your input data. Because I was also one among the member in governance team. So I had written the rules Okay, rules means the guidelines. So what the A governance team has to do. So I have also written that we will be reviewing the data, what was used, how your data has been prepared. So this new data, right? So the new data, how it was prepared by your team and what is the data. We'll also review this data, thousands data, how it is prepared, whether there is a bias in this and whether the original LLM already had some bias in it. Okay. So these things will lead to your final model's output, right? So if there was any bias in this or this, your output model also is bound to have bias, right? So it's not just testing here. We also tell where the bias came from. That's very important, right? So it's not just that testing the final output and telling that your model is bad. We, as a governance team, we also ensure that the data is not biased as well as the LLM is also. Because today, if we can correct this, you can prepare any number of LLM models without bias, right? So that's the point. So you should also review the input data, whatever you feed in, apart from just the output LLM or the workflow, which normally they review. Okay, coming back. Just give me 1 minute. Okay. So here we have so at this point we have a limitation for fine tuning, right? So limitation is of fine tuning is we cannot kill that forgetting 100%, but we can try to reduce it, right? Instead of 40% forgetting, we can reduce to 10 to 20%. But if you're not interested okay, I'm not worried about how much it forgets the previous knowledge. I am worried only about how much it is going to learn the new knowledge, what I'm going to feed in. Then no problem. You can go ahead and fine tune. But still there are some limitations for real world use case of the fine tuned LLMs. There are advantages, but there are disadvantages. Okay. What is the best output could be? Can somebody think what? See, there are some disadvantages of fine tuning, but there are advantages of fine tuning. Okay. And the disadvantages are killed by RAG. Keep that in mind. And now tell me what could be the ideal scenario, like use or final product look like?
Hi, sir, you're audible, you're thinking.
Okay. Maybe my question is not clear.
Yeah, sir, if you can rephrase it, yeah.
Yeah. So question is like, so normally this is always there is a discussion between fine tuning and RAG, right? So people always in your company, they say, okay, fine tune the LLM, fine tune the LLM. And many of the executives does not understand what is fine tuning or what is RAG, right? So they say, okay, if you are building a product means you are fine tuned LLM. If you apply RAG, they say that, array, this is this is a very small thing. What have you done correct? Okay. So that's what they say. But I don't disagree with that, or I don't agree with that. It again depends on the scenario. That's what you should say. You should never say theirs is wrong or yours is wrong. It again depends on the depth understanding of the particular scenario, right? So my question here is, there are disadvantages for fine tuning. There are advantages of fine tuning, correct? So the disadvantages are killed by RAG. Some of the disadvantages are killed by RAG. Okay. So at the final, okay, now you have option to fine tune, option to have RAG. Okay. So what should be your final output? Whether to consider RAG or whether to consider fine tuning? Take any one scenario.
Yeah,
What could
maybe
be the right way?
sir, if the process output depends more on the up-to-date information, then even from the slide it appears like RAG is better than the fine tuning. because it will fetch, because the model itself doesn't need fine tuning, just that only the data needs to be updated. So in such scenarios, probably RAG could be better option than fine tuning.
Okay.
However,
So
as you said
keeping-
earlier, like if you want to add more tasks, like more purpose for the LLM, then fine tuning could be a better option than RAG.
Very nice explanation. Even I could have not done such a good justice to the sentence. Okay, good. So that's a best thing. Right thing what you said is to add tasks to a particular LLM. To make it to do a new thing, you have to fine tune. Okay. And to learn facts in real time, the best is to use RAG. Don't make LLM to do a learn facts, right? So learning facts is very difficult for LLM. Fine tuning does not make it to learn. It can only tune it to uh, answer in a specific way, right? So it can do a different task. It cannot learn new, it cannot memorize facts. Okay. So that's the point, one thing. Second thing is that prefer to think both the things like hybrid approach. Okay. So hybrid approach, and also not always don't go for fine tuning, because fine tuning is like only once, right? So why we say that don't make LLM to learn facts is you cannot keep on feeding facts into it, right? So it's very costly. LLM fine tuning is costly. So if you have incoming data so much, you can never fine tune it, right? With so much amount of incoming data. That is one point. It is costly. So the data is too much. Computation is very high. Costing is very high. And LLM does not learn facts nicely, right? And another most important thing, which is not very much explicit, but it is inbuilt, is it cannot cite, right? That citation, right? Like for example, in all your company solutions, you wanted a reply from LLM, right? And nobody believes it. Right? Ideally, the truth is nobody believes it. They want a citation with that. So where does the answer came from, right? You tell me. Maybe the LLM or your workflow searched it in from a data set of 1,000 documents. Okay, that's well and good. It found the correct answer. It gave the correct answer. So you have 10,000 documents. One case is you have fine-tuned the LLM. Another case is you have used RAG. Okay. But you have fine-tuned the LLM. Maybe your LLM learned the facts also. But what is the use? When you ask a question, it will give you the correct answer. Maybe it's maybe it is the correct answer. Okay. I'll not say it will always give correct answer. If it gives even if it gives the correct answer, it cannot quote which document, which page it came from, correct? But your RAG can give it. So that is the advantage of having RAG. So in all the company works, you need the citations from where the answer came from. Even in ChatGPT, you go and see the ChatGPT is different, but if you ask a ChatGPT is a system, right? It's a RAG, very complicated system. But I'm talking, if you take only GPT 5.2 or GPT 5.1 or Gemini 3, right? Gemini 3 is in the top. So you just have an API key of Gemini 3, ask a question, it will give you an output. It will not say from where the output it gathered that information, correct? The citation is missing. So that is a very, very major issue. That's what is this part, by providing a clear link between the generated output and the source documents, right? So will not be possible at all in fine tuning. So fine tuning, don't use it for learning facts, because if you make it to learn facts also, it will even give the facts, but who is going to believe, right? So it's like any WhatsApp information, right? So that's not proven. But if you using RAG, then it will also quote this information. It will not take its own decisions, right? So it ports, okay, you go and check here for further information. You want to believe it, go and check there and then see. Okay, I just told you that answer, right? That's the point. So this is very, very important thing, which makes RAG more reliable for enterprise situation. But it does not kill the fine tuning. Very important, it does not kill the fine tuning. Don't consider that, okay, RAG is the ultimate output. No. Fine tuning is useful to learn new tasks. For example, you can use RAG to, like for example, you can fine tune the model to talk in a different language, right? So it talks in English today. Okay, it gives responses in English. You wanted to fine tune it to talk in Hindi. That's a task. You cannot make RAG to do it. So if LLM gives output today in English, okay, you cannot use RAG to make it to give response in Hindi. It's impossible, right? It's not possible at all. Whatever RAG you use, it is going to give the response only in English. But if you want it to speak in Hindi, you have to find it. And it will give the response in Hindi. So I think now it should be very clear that when to use fine tune. So to make it to learn to do a new task, right? Or new way of giving output. Learn new task means we are talking about new way of giving output, right? So like if you remember, we discussed about instruct GPT, right? So earlier it was giving a very, what do you call it? Very rough sentences. But once the GPT was fine-tuned with instruction data set, then the GPT has become instruct GPT, which follows instruction. When you ask a question, it will give you an output, right? In a very formatted way of output. So you have changed the way it gives out. So in our earlier case, what I mentioned was earlier it was giving a response in English. After fine tuning, it is going to give response in Hindi. So in those cases, when you wanted the LLM to give the response in a different format, different language, different way, then you have to find it. But RAG is to feed information, facts, and your LLM is going to give only the same way of response. Okay, so in that case, only use RAG. But when you wanted the, like for example, you have LLM and you have 10,000 Hindi books. Okay, so now your LLM currently knows to speak in English. It learns from English and then responds. So you give an input English text, it will give an English text output. Currently, this is the LLM. I have given it to you. But I have given you 10,000 Hindi documents. There is no English text. Okay. So now I'm telling you, make a system which can which I can use it to query in such a way that I get I will query in Hindi and it will give me the response in Hindi. Okay. And that information mostly I will ask with from that 10,000 books only. So if this is the scenario, then what you will do? You will have to take that LLM, which can take English input and give an English output, and then fine tune it using that 10,000 documents. Yes. So once you fine tune, now your LLM will take Hindi input and then give a Hindi output. Okay. So now the LLM is ready, but it is not very good at answering the Hindi queries, which I will ask from 10,000 books, because it is now ready to answer in Hindi and take Hindi, but it will not remember all the facts which was there in the 10,000 documents. Correct? Also, when you are using it in company, you want citations also. Correct? So what you should do? You fine-tuned the English to English LLM to take Hindi input and give Hindi output. That is first step. Second step, you use RAG on it. So now if the user asks a query in Hindi, it will go and search in that 10,000 documents and retrieve the relevant chunks from there, and then now use that fine-tuned LLM, Hindi to Hindi LLM. You give the relevant chunks which you fetched from there and give my query to that. And now that LLM will prepare the answer and then give you the answer to the user, right? Along with the citations, which are those 5 chunks or 10 chunks, what it has used. Understood? Am I clear here? I
Yes, sir.
explained so much.
Yeah,
Right?
yes, sir. Clear, sir.
Okay, so this is called hybrid. And of course, if you understand this, you get a question in exam, final exam. Okay, so please understand this. Okay, so if you understand this, you did a very good justice for this course. That's why. If you didn't understand, please ask. Okay, maybe I'm not very good in explaining. I'll explain it again because this is the core concept. Because anywhere you go, you ask JNA, they'll ask the first question is whether to fine tune or RAG. So if you understand when to fine tune, when to RAG, and when to do both, or when not to do anything, just use the raw LLM. You are already expert in this subject. Rest all is just a few more techniques are there, how to do what. But this is the basic question anybody will ask, right? So keep this in mind. Okay. So hallucination, yes, retrieve documents, LLM used to retrieve document. So LLM grounds it, right? So even though you have fine-tuned the LLM with 10,000 Hindi documents, it's not grounded. It will not remember all the 10,000 documents. But RAG can make sure that LLM response is only from the retrieved documents. And knowledge cutoff, yes. So fine-tuning has always cutoff, right? So fine-tuning is a bigger work. You cannot keep on doing it real time, right? So in companies like my previous organization, real time data is so much, right? So you cannot keep on fine-tuning the LLM. And first of all, thinking that fine-tuning with real-time data, even if it is possible, you should not do it because LLM is not going to remember the data points. It is only going to remember the format of the input data points and what exactly you wanted output. Okay, only the format it is going to remember. That is the most reliable way of finding. Yes, of course it will learn. I'll not say that zero learning will be done. Some facts it will learn, very few facts, but you cannot guarantee it. Okay, which facts it's going to learn, which facts it is not going to learn, and how much is required to learn all the facts. So it's better if you really wanted to learn facts, then go for a full-fledged pre-training. No LoRa and QLoRa help. Okay. But that full-fledged pre-training is going to cost you so much. That's why people use RAG. Okay. So explainability and trust I explained, and this data privacy and security is of course. So this is only inside, right? So data privacy is there. So if your LLM is inside your premises, right? So if you have self-hosted it in either in your local server or your company's data servers, then it's very, very safe. Otherwise, also, if you have API calls, consider that if you're not fine-tuning the LLMs, like this is also a governance point. If you're fine-tuned LLM, they'll ask, okay, if anybody takes your model out, okay, so the model also becomes very much proprietary. So if somebody takes the weights of the models, they can recreate your data. Ideally, it's not possible, right? Ideally means I cannot guarantee that sentence, but yes, it cannot surely recreate every data. Like I used, suppose 10,000 documents and I fine tuned one LLM. Okay. So now this LLM has become LLM fine tuned. Okay. So if suppose somebody steals this LLM, steals LLM means what? So he has stolen all the weights of the LLM and the architecture. Okay. So if he asks some queries, it may give maybe 10% maximum of this facts inside this 10,000 documents. Maybe this is proprietary documents, right? So not, I don't think more than 10,000, 10% they can take, but companies will not even accept this. But point here is, in fact, 10% is itself too much according to me. To not even remember anything. It will just remember the way you have tried to format it. Okay, fine tune. Okay. So always think that fine tuning is only for learning new tasks and drag is for keeping it more updated with facts. The same thing, whatever I say, all these things, you can save some money, but you cannot say real time is not possible. Okay. But you can see what is the advantages of fine tuning. We have already discussed that. So I think this is what I was trying to explain. So just go through. If any point here is not clear now, just ask me. Just go through this. 2 minutes. All points are matching. So this is
What
one
is
point.
per
Yeah.
so what is per query cost? Is it like for every query retrieving is like API hit or something is costing here for RAG?
Correct. So in RAG, your retrieval is also costing, right? In RAG, per query cost means, so you have to do two works in RAG. You have to retrieve and then you have to generate. Correct. But in fine tuning, you will do only generation. Correct.
Okay. Okay. So it's a one time versus
No,
every
the
time.
cost is during inferencing, it is just low. Correct. But here during inferencing, you will do retrieval as well as generation. But here only generation. So during retrieval, during inferencing, it is very less. But in fine tuning, you have to train it ahead, right? So upfront training cost is very high. Okay, but major thing what I wanted you to understand is this one. So fine tuning always style adaptation, right? So style means style formatting, like style. It's not just style. Style doesn't mean just a style word, right? So don't take it in a very conventional way. So the best example which I already gave you, right? So take a English to English LLM, and then you fine tune it. So now it takes Hindi input and gives us Hindi out. So that's a style change. Okay. So we are talking about style adaptation is that much level. Okay. So you can make it to adapt to a new style of response. But knowledge retrieval, knowledge stuff comes here. It is not going to learn new things. It is just going to adapt to a new way of taking input, a new way of giving output. Okay. That's it. Okay. And here, low latency, here it is high latency, not high, very high. It depends on which vector database and how you're using. So retrieval overhead is there, right? So it's not this much low. It will be like 1 second. Okay. It again depends on how much vectors you have, which database you are using, what are all the methods you are using, like you are using HNS, HNSW or IVF or whatever it is, right? So it depends on a lot of other things. Okay, got it. This slide is clear, right? So this is very important. Okay. So keep all these two things. So we'll play with this. Okay. During exam also we'll play with this. So understand these two concepts very clearly. Every line in this matters. So, so point is, if you understand this slide, you can answer one scenario in your exam. That's a very last question. Okay. So answer will be like just straightforward, which is which one you have to apply, or both you have to apply, where you have to apply both. Both you have, don't write simply, okay, apply RAG as well as finding. No, that cannot be the answer. So as I mentioned, like in my example, use fine tuning to make it to learn to take in the input and give a in the output. This is the requirement of fine tuning. And RAG is to use the same 10,000 documents as a RAG database, vector database. Using RAG, you retrieve the information in real time for the user and then augment it with to your fine-tuned LLM and then use it. You understood, right? So that all the architecture. Should I draw that and explain what I explained? I didn't draw anything. Did you understand what I said? Do you want me to explain that? No, right? It's clear, right?
Sir, clear, sir.
Clear, right? Okay. So please learn. That is not so complicated. It's very simple. Yes, but keep that in mind. Okay. So we'll twist that and ask something. Okay. And so this is you understand, right? So it's like you take, so for a given query, what is the answer? Right? So how do you get in RAG? You will take so query and the retrieve documents, and then you will answer. Okay, you will not simply answer from the query. And where do you get the documents, retrieve documents as per the query? So for a given query, you will retrieve the documents, and from the documents and the query, again you will find the answer. Okay, that's the complete solution. So that's the point. So just all these things are being built. RAG, does anybody want more depth explanation? RAG. So this slide, everybody understands, right? So any questions on this slide? Or any point did you not understand? Is it clear? I know RAG is very simple concept, right? Maybe 1 year before it was very complex. Nowadays RAG everybody uses. Those who know, those who don't know also they use.
The general
Any
concept is
space.
clear. Anything specific highlighted in this chart, sir, like that we should understand?
No,
Otherwise,
no,
RAG
this is a
concept as
very,
such
very
is,
general stuff. We'll go through the in detail later. This is
yeah,
just a general concept.
yeah,
So for a
please,
given query, we don't answer, right? So we
yeah,
don't give, so it is like without RAG, right? You see here. So for a given query, we give an answer, but this is not good, right? So this is directly you are taking the query and then you are answering. That is not good. So what we are doing is taking the query and then retrieving it from the vector database, facts, or whatever it is, and then you are augmenting the question with the retrieved chunks, and now you are trying to find the answer. The same LLM you are using. Okay, here also LLM will come. So anything
yeah, that I
is
got it. Okay.
oops, works. Save and save. This is the most simplest right. Okay. Came in 2024 survey. So now we'll enter the complicated stuff. Okay, not so much complicated. We'll see some of them. I will wish you guys will discuss a little more on this also. Like whoever will do the assignments, right? So later you can discuss any one formatting. Formatting means any one format type, data types, not data types, formats, document formats. Like we'll discuss mostly of PDFs, but in real life, right, you will always also get different other types. Docx, PPT, PPTX, XLSX, right? XLX, CSV, .md file, HTML, TXT, lot of other. Yeah, somebody else something? Did I miss anything? Fine. Okay. So basic thing in little more detail, the same thing in little more detail. So there are two steps in RAG, right? So first one is the offline processing. That's we call it as indexing. Okay. So this part is very important. This part. Okay. So this is where you what do you say? Prepare the system. Okay. So two pipelines. This is indexing pipeline. This is the chatbot pipeline. Chatbot or chatbot pipeline. Okay. So in the indexing pipeline, what we do, we have like, for example, I was talking about like 10,000 documents, right? So you have 10,000 documents. You take that, do a chunking. You'll see what are all time chunking methods we have. So chunking means, what do we mean is, we split the document. Say, like for example, one document will be like 1,000 pages. We are not talking about one-page documents. Okay, we are talking about 1,000 pages. So one document is 1,000 pages. I cannot vectorize 1,000 pages, right? So why is it so? Can somebody say, what if I vectorize one document into one vector? You should know this, right? By now. We discussed that during our vector creations, vector hybrid architecture. So I am saying that, okay, I'm saying that one document, one vector at this, and then I send it to vector D. Is it correct or not correct? And my one document is 1,000 page. Is it correct or not correct? If it is correct, why? If it is not correct, why not? Am I
It is
audible?
not correct. Yeah, yes, sir, you are audible. It is not
yeah.
correct.
Mhm.
Why I am not able to recollect from the class, but my
Okay.
guess would be that it is like
Right, no problem. I'm asking too many questions today.
Yeah, chunk should
Okay.
be small. There should not be larger documents.
Why?
embedding
Otherwise,
will
you will get irrelevant answers apart from the relevant answer.
Why?
Because
somebody was answering correctly. Yeah. Tell me. Yeah, go.
Because the semantic relation, you should not already RAG is implemented to address hallucination. And by having larger document as one vector, when you are retrieving from that vector, it will give you a lot of information, which most of the thing is irrelevant and only some part is relevant.
It's a wrong statement. The wrong statement is lot of information. Why also can answer this question. So see, point is when you are having lot of pages, right? So lot of data. For example, instead of 10,000 page, I'll say that okay, I have 10,000 points. Okay. So I have 10,000 points and my vector size is fixed, right? For example, even though currently I guess there is a vector embedding model of 4096. Okay, I think the embedding model, the output vector size is 4096. This is the maximum, but we normally use around 1024 or whatever it is model we use. Okay, so generally this is used. Okay, so as of now, I have seen around 4096. Maybe it is 8190. Sorry, 192 is also there. But currently, what I'm saying is, whatever it is, there is a limit, right? So it is like 4096. So if you remember a vector, so if you take a vector is a set of attributes, correct? So every vector represents some attribute of your text. So you give a text and you send it to an embedding model, it creates a vector. Okay. So what this embedding model, when it creates a vector, what it does is uh, you can visualize, like you can think it like the text syntax is covered in this number, grammar is covered in this number, some token values are covered in this number, correct? And correct. So each vector, each number of the vector takes one attribute, correct?
Yeah.
If you give so much data, like 10,000 points, do you think this 4096 or the general term 1024 attributes will be able to cover the 10,000 points in a crisp way? Not possible, right? So it
Yeah.
will get lost. That is first point. Second point, I also told you before uh, mid-exam that your vectors, how does the vectors form? So you should understand this. Like for example, you take the uh, text. Okay, this is your text. So I say token 1, token 2, token 3, token 100. For example, 100 tokens are 100 tokens means you can consider as like words. Okay. So when you send it inside one embedding model, okay, what it does is, so it will be inside the model only. So when you send it inside an embedding model, right? This text, this is the complete text you are sending to an embedding model. And what is your embedding model output? It outputs a vector of 1024 size. Okay. So this is the 1024 size. But what happens inside is, so every token is creating one vector. So this vector size is 1024. Okay. So same way this vector. Now you understood? Every token is created, is converted into one vector. Okay. Inside the embedding. At the last, what they do? Pooling. Correct?
Yeah.
So all the averages, right? The first number of all the vectors are added and then averaged. And then you put it as the first number here.
Yeah.
Okay. Now you see, if instead of 1,000 words, I put 10,000 words, this average will be too much diluted. Do you agree?
Yes.
That is the reason. That is why you should not go for a very good, very big chunks. Okay. Got it? So this
Yeah.
is the major reason you should not go for a very big chunk. So in in a very layman's language, I explained this, but technically this is the reason. Okay. So you should not go for a very big chunk. So ideal number, in fact, I told this also before mid exam, 512 tokens approximately, not strictly 500. You can go from 400 to 700, 750. Okay. So approximately you can target around 512 tokens. Or approximately, if you want to consider words, then it's around 400 words. 350 to 400 words. So one chunk, one text should be around 400 to 300 to 400 words. Okay. So only that much has to be created into one vector. So that is why we need to do chunking. So documents which has 10,000 pages, for example, I take one document. Okay. So it has 10,000 pages, right? So 10,000 pages means you consider some one page, suppose 2,000 tokens, 1,000 tokens. Okay. So it will be simple for me to. So 1,000. So it will be one document will be 1 million tokens. Correct. So approximately 1,000 tokens I have taken per page. Okay. So 1 million token. So I cannot use this 1 million tokens to create one vector. This is not correct. Okay. So what I do, I split this into different chunks. So how many chunks I can create? So consider 500 tokens I want to take. So 500 means to 2,000. So 2,000 chunks I will create for one document. Correct?
Yeah.
Not exactly 2,000. We will have some overlap also. So you can consider 400 only in that case. So 400, so approximately 400 you can take. It's 400, so 25, 2,500. Correct? 2,500 chunks. Okay, so you will see overlap next class, but 2,500 chunks will be prepared. Okay, that is the chunking. So now each of the chunk you have to embed it and then create 2,500 vectors. Okay, and this 25,000 vectors you will store it in your vector D. Okay, so this is the first part, which is the indexing part, indexing pipeline. Any doubts here? No, right? All clear, no?
Yeah.
Okay, so now we have done one part, we have prepared. Okay. So we have 3 minutes, we can complete this pipeline. This is a simple pipeline. Then we'll go into deep. Okay. Each of these steps will go into deep. Okay. So this is just overall. So now in query time, like in real time chatbot works in real time, right? So when you are doing querying, so now the vector DB has the vectors, right? So the vectors are here. So for example, you have 2,500 into 10,000, right? So 10,000 documents. Per document, I have 2,500 vectors, for example. So 10,000 means it is like around 2,500 into 10,000. So it is around 25 million vectors I have. Okay. This is the production scale system. Okay. So we're not talking about something two documents or something. Right? So now we have, this is the first step we have done. Now during real-time chatbot, a query is sent by the user. Okay. So what it does, it goes into the vector table. The query is sent to retrieve means it is using the vector table, this vector table. The query is sent and the vector, it will do that HNSW, right? If you remember, that's the what we learned before mid-exam. So it will use the HNSW logic and then retrieve it very fast, right? So what it will retrieve, it will retrieve the context. It will retrieve the vectors and corresponding text will be there, right? So whichever chunk which was used to create that vector, maybe top 5 chunks I am taking. So query embedded, not exactly the query they will send. The query will be converted into vector, and then so vector of the query will be sent to the vector database, and it will take the top 5 vectors, and then corresponding chunks will be brought in to this place. Okay. So, and then once it comes to here, so this is the context. This is what we are calling it as 5 chunks for this example. Okay. And then this query is exactly which came from here. So now you send it to LLM. So the LLM will receive these 5 chunks and the query, user query. And then LLM will generate the answer and then send it to the user. So when it sends the user, along with that, it will also send the chunk data or the chunks came from which document, right? So that you will, that also information you will have it here. You know, along with the HNSW, you will have the vector, you will have the chunk text, okay, and also you will have the document name, right? So this is the original document name. This is the chunk text among this 2000 and that particular vector, which was here, right? So like this set you will have in your vector DB. So vector DB will search in this vector and find the top 5 vectors matching with the query vector, and then corresponding text and then corresponding document name, it will send it to here. So corresponding tongue text is used here along with the query. The answer is generated, and when the answer is sent to the user, along with that document names of the 5 chunks, right? So 5 chunks which was used here. So uska document names, like maybe it can be 5 documents, 1 document, 2 document, like document name. So it be some maybe overlapping. The chunks may be from same document itself, right? So same document. So that also. So just that 5 document names you maybe it is a good thing about it. That you can do. Understood? It will get. Understood till here?
Yes, sir. Thank you.
Okay. Okay, we'll see next class what we think after your makeup exam. Okay, thank you. Any
Sir, one
questions
last
you
thing.
can ask? Yeah.
Okay, quiz 1 and assignment 1 was not graded for most of the students still.
Quiz 1 and assignment 1. Assignment 1, you will, I think you can see the marks. Quiz 1, I have not opened the marks.
Okay.
What do you want quiz 1 marks? I have not even opened. You will get it by the end of, anyway, you will get it by after the assignment 2 also. Because all the marks should be open to everyone. But quiz 1 marks are not visible to anybody. I am not opened it to anyone. Okay, you want it?
Yes, sir. Can you open it?
What is the use of that? Just saying the marks and being happy. Won't be like me. I also used to worry like this. Don't worry. You, sir, you are telling about me. I was also like this only. I used to worry, this area, I should be getting 5 target. Hello, I will open. Maybe I can feel your heartbeats. Nothing will happen. If you see or don't see, the marks will go to remain same, right? But still, that heartbeat will be there, right? I can feel it. But okay, I'll open it. I'll open it.
Yeah, thanks. Sir. And, yeah, an assignment, some of us have not got evaluation yet. So just want
Assignment,
to, yeah.
Okay, I don't know. I'll check with the PAs. I thought they have completed it, but I'll check. Maybe they have not completed. I'll check with them and then let you. Okay.
Okay, sir. Thank you.
Okay. Thank you all. Some chat is there. Okay.
Yeah. Thank you.
Thank you.